O meu privilégio agora é apresentar o Pekka Räsänen, o nosso próximo palestrante, que é um pesquisador importantíssimo na área de cognição numérica e educação matemática na Finlândia. Mas antes de apresentar o Pekka, eu vou aproveitar e fazer uma propaganda. Então, a propaganda que eu queria fazer é sobre o livro que foi editado pela Anne-Marie, pelo Pekka e por mim, o International Handbook of Mathematical Learning Difficulties. O Pekka é um pesquisador por quem eu tenho uma enorme admiração. Ele é uma das pessoas que mais conhece sobre políticas públicas na área de educação matemática no mundo inteiro. Ele é neuropsicólogo, né? Também tem um interesse muito grande sobre tecnologia computacional na aprendizagem da matemática. Eu fico extremamente feliz que ele tenha aceitado participar do nosso evento, porque eu sei que atualmente ele está com nada mais, nada menos do que 3 empregos diferentes em diferentes institutos de pesquisa na Finlândia. Então, Pekka, muito obrigado por ter aceitado colaborar conosco. A palestra dele vai ser sobre aspectos históricos, conceituais do diagnóstico de de dyscalculia do desenvolvimento. O ano passado, ele coordenou um importante evento na Suécia, comemorando o centenário da descoberta da acalculia pelo neurologista sueco Solomon Hensch. E ele vai trabalhar em cima disso aí, né? Quer dizer, dessas ideias, né, da neuropsicologia sobre habilidades de processamento numérico e cálculo e sua eventual aplicação na área do desenvolvimento. Eu nem precisei chantagear muito o Pekka, ele aceitou logo participar do nosso evento. Aproveitem, divirtam-se, aprendam bastante.
Good afternoon or good evening. I don't know what time it is there where you are listening. My name is Pekka Räsänen, and I'm supposed to talk in this online congress about the definitional and cross-cultural issues in developmental dyscalculia. To start with the historical ideas, we can look at a Swedish neuropsychologist and his work on calculations. He was interested in speech, music, and numerical processes. At that time, 100 years ago, there was not much research done on calculation skills, and he was one of the few who paid attention to both spoken and written numerical processes. And in his talk to the Swedish Medical Society in 1919, is one of the starting points of the research area we're talking today. And in this talk about spoken music and calculation mechanisms in the brain, he said that digit and number operations are a peculiar psychic process with a specific anatomical basis which must be separate from that of words. So he was talking that the ability to calculate bears no relation to the different forms of aphasia. He claimed that the calculation process is something specific and separate from all the other processes. And especially to describe this difference, he described the difficulties in mathematics only, irrespective of aphasia or something else, with a new word which he invented to describe, and it was acalculia. After Hansen's original work, the word acalculia and later its developmental form dyscalculia, presented by Czech researcher Vladislav Kosk in 1974, it has ended to the literature of neurology, psychology, and education. And today, 100 years later, when we look at the developmental dyscalculia, we can see 3 different diagnostic or definitional approaches for it. The first is what is called discrepancy model. The second is strengths and weaknesses model. And the third we can call as a response to instruction or response to intervention model. And we will look at these a little bit more carefully. The discrepancy model is the classic approach which is dominant in medical diagnostic definitions like DSM or ICD, where the person's mathematical skill is contrasted to his IQ and compare that in a similar cultural and educational context. So the math diagnosis is always based on people living in the same culture and having similar kinds of education. The interesting thing in this approach is it doesn't say anything about the treatment. So you have a diagnosis without any connection to what kind of treatment is needed. So the discrepancy model typically goes like this. You first look at persons with IQ above certain criteria, typically, for example, 1 standard deviation, ending up that you are looking at population of 84%. Then you add here those who have math below certain criteria, 1 standard deviation, 1.2, 5 standard deviations. But when you compare these, combine these two, you actually get this smaller group of persons. Some of them are excluded because of the level of IQ, and some are excluded because of the level of math. Typically in text books, it's described that the prevalence of developmental dyscalculia is from 5 to 7%. But when we look at the research done, researchers have used different criteria for the low math performance, up to 1/4 of the kids to very strict about 2%, and lowest 2%. There's a huge variation in definitions within the discrepancy model. The second approach is still concentrating more on cognitive skills, but it's not so much interested in the full-scale IQ or the general cognitive level, but the variations in individual cognitive profiles. This is more a clinical approach, which is used by clinical psychologists and school psychologists, trying to understand the mechanisms behind the difficulties in learning mathematics. So it tries to connect the math difficulties to more domain general cognitive weaknesses to understand the roots of the difficulties, and also the strengths to understand what kind of interventions would be suitable for different persons. This is not so common in research, but in research, these cognitive profiles, which are most common and which could be explained why some persons have difficulties in mathematics, have been done. As an example of this is a large-scale study done in Cambridge with more than 1,000 kids, where they try to connect the cognitive weaknesses and strengths to developmental dyscalculia. So the starting point here, pointed in red, is that you have a group who have developmental dyscalculia based on their math performance compared to the normal general IQ. But the interest in this research was, what are the weaknesses and strengths in cognitive profiles? And the result is that visuospatial short-term and working memory are on average lower than, for example, verbal short-term memory and work. So we have certain weaknesses in developmental dyscalculia and certain strengths. The third model is the response to instruction or intervention model. And this is actually the only model that tries to control the biggest unknown factor, which is left open in the other models. It is the education. In that sense, we could say that this is an educationist model, and it's not so much interested in IQ or in different cognitive strengths or weaknesses. And dyscalculia is defined in a way that intervention does not produce a sufficient improvement in learning. And the intervention is selected on the basis of the current level of the math skills of the person. In the early models of this response to intervention model, the researchers used a standardized interventions. So these children were giving exactly the same intervention. But step by step, it has changed and moved to more dynamic interventions model, where the interventions are tailored based on the individual needs. Because we know that standard interventions, one intervention doesn't work for all. So typically, the response to intervention model defines two levels of kids. So we can look, there's certain threshold criteria that after certain intervention you should reach certain level, or you can also look at how much you have improved. So what is the slope of the improvement? But can we use the response to intervention model to estimate the prevalence of dyscalculia? Because there are a lot of questions connected to response to intervention. So for example, what is the role of IQ in responsiveness to intervention? So if you have very low IQ, it's most probably the case that you don't benefit from intervention in the same way if you are an average IQ person. So we still have to exclude those with very low IQ who may not understand the aims and the communication in interventions. And so this has to take the response to intervention model closer to the discrepancy model. Some IQ criteria has to be used. We also know from the strengths and weaknesses model that persons with different cognitive profiles react differently to different interventions. That's why how to build up a response to intervention study with different kinds of individualized dynamic interventions. It's not so easy. So, and the third question is, in this is how do we define the improvement? We can look at the final status of the kids. So we took low performers and we'll look at where they reached at the end. We can also look at the slope, that how much they improved, or we can use both. So we can use a dual discrepancy. So we look at both the final status and how much they have improved. This is the best model where you look both of these, because here in the image you can see that there are two cases presented with the blue color. One which is starting just below the criteria, but not developing a lot, but enough to reach the threshold criteria for dyscalculia. And then there's another group which starts from very, very low level, but improves much more than the others, improves almost the same speed as typically performing, but doesn't reach the criteria. And this kind of cases cannot be accepted as dyscalculics because they actually respond to the intervention. So dyscalculics are those who do not reach the criteria, the threshold criteria for learning, and also they show a very, very slow improvement. To study this, we conducted a follow-up study in Finland with 5 years of follow-up. And why Finland is a very good case for this kind of studies, we had a sample of almost 2,000 kids, and we measured them 5 times from 1st grade to the 5th grade, excluded the persons with a low IQ, but the Finnish educational system provides an excellent field study possibility because the intervention is actually implemented as part of the whole educational system. In every school, we have specialized staff to take care of kids who have learning needs. We have special teachers with 5 years of academic training to conduct this kind of support. Our legislation says that every child is or can have or should have support immediately when need, without any requirements for any diagnostic procedures before that. So almost all the kids have a chance to have individualized support, so dynamic intervention. And during the school years, almost 1/3 of your pupils do get individualized support in reading, in mathematics, and in other subjects too. So Finland produces a case of response to instruction or response to intervention as an educational system. Within this system, we studied the development of these almost 2,000 kids and looked at the development of arithmetic skills from the beginning of the 1st grade to the end of the 4th grade. And the best model to describe the development in groups is a 5 groups model, which defines the high performers, the top performers, and low performers, average performers. And when we standardize these values, we will see that the lowest performers start from approximately from the same level at the beginning. But there's a low performers, the blue group, which is actually hanging out rather well with the education, even though they are still at low level. But then there's this orange group, which is actually lagging behind more and more. The gap between them and the others, it's increasing. And it's increasing so much that at the end of the 4th grade, they are already 2 standard deviations behind the others. About 10% of the sample was excluded because of the low IQ performance. So interesting here is that when we look at those 2 groups, we can take the strengths and weaknesses model and analyze that why these end up to have different pathways of responding to education. The results are basically here, the group differences are here, but I simplified this graph to this color table, where up you can see the 5 groups: MLD, mathematical learning disabilities; LA, low achievement; TA, typical achievement, and so on. The color indicates that there is a statistically significant difference between the groups before the start of the school. So the low achievement and dyscalculic group differed in counting skills already before the school age. And they also differed in spatial skills, processing speed, and nonverbal reasoning skills, but not in vocabulary or reading-related skills, or, interestingly, not in parental education. And there were no gender differences in the lowest performers. Secondly, we will pay attention to cross-cultural issues. Can we conduct the exactly same kind of study in other educational cultures, like, for example, in Brazil? Here is the PISA 2015 results in mathematics, the 9th graders. And you can see there's a dotted line taken from Finland to Brazil. But the result is pretty much the same in other Latin American countries. If you take the lowest 10th percentile of the Finnish kids, so those who are close to the level of to be defined dyscalculics in Finland, you can see that their performance level is slightly above the average performance in Brazil, and the same level as the average performance in, for example, in countries like Mexico or Uruguay. First, you might think that this is because the Finnish educational system is asking the kids to learn more. It's more demanding in Finland. But actually the result is totally different. In our international handbook on mathematical learning difficulties, we did look on this issue a little bit. And here are examples, and in the square you can see the difference between the Finnish and a typical Latin American syllabi for arithmetic. When in Latin American countries, typically the children are doing addition and subtractions with multi-digit numbers. In Finland, at the same time, in the first grade and preschool, the Finnish kids are still playing with numbers below 20. And here is an example about what kind of things kids are doing in Mexico at the end of the first grade. So they are playing with series of adding with 4, or they are doing multi-digit addition tasks. At the same time, the Mexican kids are doing this kind of calculations. In Finland, the kids are playing with numbers which are below 20. We have conducted several studies using the same test battery in different countries, and that allows to make a simple comparison in very basic arithmetics in the first grade and how it has developed. So we have data from Mexico, Ethiopia, Zambia, and Finland. And I will present you a short summary of the kids' performances in addition and subtraction from different studies. So this is not one study, but we have multiple samples, and we can combine those samples to analyze and look at the performance levels. So we have different samples from Zambia. We have a national sample with all seven official languages and different areas. From Finland, we have samples from the beginning and the end of the first grade. In Ethiopia, only 2 language areas were studied, Amharic and Oromo, which are the biggest language areas, but also from data collected from both cities and rural areas, trying to reach some sort of normative standardized data from these language areas. In Mexico, we have a special sample, which we followed 3 measurements during 1 year, and the sample contains middle class and working class areas, so with more kids from both performing areas. We have 3 measurements from 254 kids with this same assessment tasks. Here's the average performance with these 8 tasks in different languages. Mexico, 3 measurements, Ethiopian at the end of the year, Zambia at the end of the year, Finland at the beginning and at the end of the year. And here's the average performance in subtraction of the same children. But this may not be so interesting. More interesting is the performance in the individual items. Here's an example of the Mexican kids. Remember that at school, at this time of the measurement, the kids were doing multi-digit addition and subtraction tasks. Tasks which had answers close to 100. But in reality, in the assessment situation, immediately when we reached the level where the children had to use numbers which are above the number of fingers, they started to commit errors. So tasks like 9 plus 7, almost half of the kids were not able to do it correctly, even though at school they were required to do much demanding tasks. And the story is the same with subtraction. So immediately when we go above 10, the children are more than half of the kids fail in performing them correctly. And if we look at the results for these individual items from country to another, we can see that the 1 year in the Finnish educational system causes that most of the kids are able to do almost all the tasks, but in African or Latin American example, the tasks which require performing with numbers above 10, they start to show problems. And it's even more clear in cases where we are doing subtraction tasks. And if we take the Finnish kids as the standard here, we can see that the Ethiopian and Mexican kids actually in the first grade, their performance level is already at the dyscalculic level if compared to the Finnish kids. the same amount of education in these in all these countries, but the performance levels are very, very different. And subtraction, the situation is even clearer. So you cannot really compare the amount of education and what kind of effects it causes to learning. So let's summarize these results. First of all, 100 years ago, Solomon Henson, a Swedish neurologist, said that there's a thing called dyscalculia, and that is a separate brain-based disorder. Now, 100 years later, we know that there's also a developmental form of these difficulties, but we still have no clear definition how to define the developmental form of dyscalculia. The definitions of developmental dyscalculia, typically the main criteria is a poor performance in basic arithmetic. And irrespective of the definitional approach, it seems that we get similar prevalence estimates of poor performers if we are assessing those in cultures which have a high average performance levels, like countries like Finland. The same criteria of basic skills learning cannot be used from one country to another, because in some educational cultures, the amount of instruction what is given, it doesn't really produce a reliable criteria for dyscalculia, because the instruction doesn't produce such effects that children would learn. So without evidence-informed educational reforms, it will be very difficult to differentiate poor learning due to conditions from poor learning due to dyscalculia in most of the developing countries. And there's a really urgent need for studies of well-functioning interventions. And these studies should especially be done in countries with low average levels of performance in mathematics. Like we summarized in our book, we say that globally, 6 out of 10 children and adolescents are not able to read or handle mathematics with proficiency by the time they are of age to complete primary education. This number exceeds with multitude of those considered to have learning difficulties or disabilities in mathematics. Therefore, the first and most urgent question in mathematics education globally is not dyscalculia, but how to improve the overall quality of education and how to offer proper learning opportunities for all. Thank you very much. I'm happy that Santa Claus gave me this opportunity to give a talk. In his introduction to me, he said that he didn't have to blackmail me, but we all know that Santa Claus never has to blackmail anyone. He just has to ask. Thank you very much.
Thank you very much, Pekka, for your very nice lecture. So it's really amazing. Lots of knowledge for us. And well, I'm very grateful to you, really, that I didn't need to blackmail you. You are so kind to accept our invitation. Yeah? And it is an honor for us to have Pekka Räsänen in this conference. He is one of the most renowned experts in the field of math education. And I think that some people here, most of the people would be interested in knowing a little bit more about these cross-cultural issues in math education. And Finland is one of the countries who has a very nice educational system. And here in Brazil, this is usually taking as some sort of role model. So in our book, the International Handbook of Mathematical Learning Disabilities, there is a section on cross-cultural issues in math education, and you wrote a nice chapter on the northern countries. So, and I know also that you have a lot of experience with math education in Latin America. I would like to hear from you some ideas about where do these differences come from, and what could we make in order to improve our situation. And as you pointed, it's really difficult to make cross-cultural comparisons and to translate or receipts from one country to the other.
Yes, it's very difficult to import or export educational systems, because education is never functioning in its own bubble. It's connected to the whole society. So if we look at all those international comparisons, how things vary from one country to another one, we can see that one of the key elements of successful educational system is some sort of economical stability in the society, the amount of poor persons in the society. But it's not only that. There's a huge amount of things which can be done within the educational system itself. Very often it's said that yes, we cannot reach the high levels of performance because there are no resources. The teachers are not paid enough. Teachers don't have high qualification education. But we can just, like in our book, we try to explain that the first step and first place where the focus is actually the curriculum. So what the kids are expected to learn. And the interesting thing is that the curriculum itself tends to be a very political issue. There's very little discussion about the science behind the curriculum planning. And there is a very little research about how different educational approaches have an effect on the performances of learning. And even though there are results, then the reforms are not usually based on research and evidence. They are not evidence informed. I wouldn't say that they can never be evidence based directly, because education is a very complex interaction, but they can be evidence informed. And one of those things where Finland it's a good example is that if the starting of the education happens slowly, so you try to confirm that everyone learns the basics, then it means that actually you can proceed faster and later and above grades. And the interesting thing is also that the change what Finland made was that we changed from this educational system which was not unitary to all. We changed to a very equal educational model. So our system varies, for example, totally from the approach what they have in Chile, where they have 3 different streams of education from early on, and meaning that your destiny is really decided at very early age. We have the same education system up to the age of 16. And so keeping equality as a model in education is a very good approach to as educational policy. So Finland is not the only country which is producing high quality education and high performance levels. The Asian countries are actually producing very high results, and many countries for example in Latin America are trying to mimic what has been done in Asian countries. But again, we have this problem that if you look at the Asian learning culture, it is very demanding on the amount of hours spent on education. So that can you import the Asian work culture at the same time to the circumstances what they are in Latin America? Most probably no. You have to find your own ways how to combine all this evidence about what is good education. And one big problem is that we know that for average and high performers, this kind of more open, student-centered, discovery-centered methods of education work well. But those kids who are poor performers, direct instruction and teacher-centered approaches seem to work better. So how to build a compromise in the educational system that you take the different kids at different levels into account in your education. So there's a lot of information available, but the big question to me as a researcher is how to take politics away from educational decision making.
Yeah, this last point that you raised, it seems to me very interesting, because as you are saying, so this discovery learning model is more suitable for kids with a better performance, probably from a middle class background, and a more instructional, direct instructional approach should be more suitable from kids from a poorer family background. And this is exactly the opposite of what educationalists are saying in Brazil. They believe that this discovery learning approach, or a more contextualized approach, should fit better the needs of kids from a poorer background. And you were saying exactly the opposite.
Actually, it's not me saying that. This compromise between this discovery, open learning environments, and very teacher-directed models, this is some sort of a consensus result from all the international comparison studies, that what seems to work. And we can also, so these are also results from the intervention studies with poor performing kids, that if you vary the education, the better effects you get with more direct approaches and teacher-centered approaches in education. So if we're staying in the context of response to intervention models, clearly it seems that dyscalculia treatment has to be based on very structured, teacher-centered approaches, because kids with dyscalculia do not have the capabilities of self-initiated activities with numbers.
Could you tell us a little bit more about your experience as a consultant for several Latin American governments on this field of math education, and also on the research that you have conducted? Yeah, so which kind of project are those? Yeah.
Well, I really can't tell you that, because I'm saying that yes, I'm just saying that the politicians do not listen us experts. I participated in several meetings or seminars with politicians, but it is that they are listening researchers with interest, but then the actual decision making doesn't seem to be based on local research. And then I add here a very interesting finding what actually you, Vitor, made in the forthcoming special issue, what we made about the numerical cognition research in Latin America, which should be coming out maybe within this month in Estudios de Psicología. And when you combined those findings from Latin American countries, actually what you found was that even though in Latin American countries there's more and more research going on these issues, and there are research groups in Latin America doing research, but the collaboration happens to US and the collaboration happens to Europe. But between Latin American countries, collaboration is almost non-existent. And this is interesting because the context of learning about the educational systems and interventions should happen more within Latin American context than from one country to another. And that would be the fruitful way of developing the education. And that is something what the politicians there should actually understand, that cross-cultural studies within Latin American countries would be extremely fruitful for the development of education.
Well, we can invite you to help us to do that. Yeah, then we would have a fourth job.
I'm happy to do that as long as we get rid of this corona time, and you and we will get away from our isolation and these beautiful islands where you can see us discussing about these issues.
Okay, thank you very much, Pekka. It was very kind from you, very instructive, yeah, for us. I think you really nice lecture and nice discussion. Yeah, ciao.
Thank you very much. I hope that the collaboration between our country and Latin American countries will continue as fruitful as it has been. Thank you very much.